layout. The direct assistance to the rack enables low friction and inertia, which in turn gives an ideal steering feel. In these systems, active control, as it is known, provides constant feedback from sensors in the vehicle to the control unit, which calculates sophisticated computer algorithms. This allows the steering system to react to the road, the weather, and even the type of driver, and provide assistance to the front or rear road wheels independent of direct driver input. Active steering produces enhanced steering, response, stability, and handling improvements to the vehicle without impacting the base steering feel. A steering sensor is located on the input shaft where it is bolted to the gearbox housing. The sensor performs two different functions. First, it is a torque sensor. It converts steering torque input and direction into voltage signals for the ECU to monitor and convert to a binary code. Secondly, it is a rotation sensor, which converts the rotation speed and direction into voltage signals for the ECU to monitor and convert into a binary code. An interfaced ECU circuit that shares the same housing converts the signals from the torque and rotation sensors into signals that the ECU can process and provide an active output. The microprocessor control unit analyzes inputs from the steering sensor as well as the vehicle's speed sensor. The sensor inputs are then compared to determine how much power assist is required according to the forces capability map data stored in the ECU's memory. This map data is pre-programmed by the manufacturer. The ECU then emits the appropriate command to the power unit or current controller, which supplies the electric motor with the necessary current to activate. The motor then pushes the rack either to the right or left. Direction of rack movement is dependent on which way the voltage flows. Reversing the current flow reverses directional rotation of the motor. Increasing current to the motor increases the amount of power assist. The electric power assistance system has three operating modes. In normal control mode, left or right power assist is provided in response to input from the torque and rotation sensors inputs. The return control mode is used to assist steering return after completing a turn. The damper control mode changes the vehicle's speed to improve road feel and dampen kickback. If the steering wheel is turned and held in the full lock position and steering assist reaches maximum, the control unit reduces current to the electric motor to prevent an overload situation that might damage the motor. The control unit is also designed to protect the motor against voltage surges from a faulty alternator or charging problem. The electronic steering control unit is capable of self-diagnosing faults by monitoring the system's inputs, outputs, and the driving current of the electric motor. If a problem occurs, the control unit turns the system off by actuating a fail-safe relay in the power unit. This eliminates all power assist, causing the system to revert back to manual steering. An in-dash EPS warning light is also illuminated to alert the driver.
Higher voltage electrically assisted power steering. There are higher voltage electrically assisted power steering systems were developed for modern hybrid vehicles. The higher voltage battery system of the hybrid vehicle provides all the power, with no reliance on engine or hydraulic power. Some early hybrids simply used the 12-volt system that was used on gasoline vehicles, but newer models are using voltage as high as 56 volts. Orange wires in the car that is hybrids, orange wire are high voltages. Stay away from those. If you go in a shop or a dealership, they will send you to school for hybrids, okay, for whatever hybrid they usually work on. Don't touch the orange wires. It's not good for you. Okay? Orange. High voltage. Big zap. Doesn't feel good. Alright. Let's take a break. It's 9 o'clock. Gloria, did you bring your crossword today?
No.
You didn't bring your Kyson?
Yes, I did.
You should bring it inside
Okay.
so we can look at your EPS.
Okay.
Okay? And figure out what's going on with your hair.
Okay. It turned off.
It turned off again?
Yeah.
Do you have stuff on your seat?
No.
No? When you were driving here yesterday, did you have your backpack on your seat?
Yes.
Probably not. So just look at your EPS
Okay.
and figure out what type of EPS it is.
Can I bring my car tomorrow? My other car?
Yes.
It needs an alignment.
Okay.
And I think the tire has I think the tire is bad.
Okay. Absolutely.
So we meeting out in the shop after break? Or?
Yes, sir.